Good evening, ladies and gentlemen. On this week's training, we're going to be looking at electric vehicle charger fires and electric vehicle fires. So we're going to dive into how to identify it, how to immobilize it, how to disable it. We're going to look at the specifics of electric vehicle firefighting. We're going to look at the specifics of electric vehicle charger firefighting. And we're going to look at the complexities and the similarities between electric vehicles and ordinary combustion vehicles. So with that, we're going to head out. We're going to go on a little field trip for a quick bit. Once we come back from the field trip, we're going to dive into a couple of programs through the NFPA and through advanced extrication, and we're going to do a deep dive on this. So enjoy, and we'll see you out there. Okay guys, so our initial run up onto the scene, either our initial pumper or pumper 5 is going to capture the hydrant over at the high school. We're going to lay in. We're going to come up into the driveway area. We're going to stage far enough back because there's going to be, during the day, there's a lot of vehicles in the yard. And then our charger is located directly on side Charlie of Scotiabank. Okay, so as you guys can see, our electric vehicle charger is located here on side Charlie of Scotiabank. One of the primary concerns during the day that I want to address is that the parking lot right here is normally full. Two parking spaces, and these are going to provide extreme exposure risks to any vehicles charging at the vehicle charger. So we'll go ahead and we'll look at the charger. So this is an ABB Terra 54 electrical vehicle charger. It's a level 3 fast DC charger. This is the physical charging unit. These are the charging handles that will go into the vehicle. This is the transformer unit. So this takes 480 volt line voltage, transforms it into 500 volts DC. There's a secondary shutoff switch located here on the right hand side. If we go over here and we follow this cable up, it goes into a junction box which goes into the building where our main electrical shutoffs will be located. Hopefully later this week we'll get a video on where they are located in the building and how to properly shut those down. Be mindful that the large disconnects need to be locked and tagged. So we have a lockout tagout kit in rescue. Once they're deactivated, need to be locked out. Okay guys, so talking about what kind of power is being pushed through these cables. So on the first charger, it is a 50 kilowatt, 500 volts DC, 120 amp charger. The second one's 50 kilowatt, 500 volt DC, 125 amp charger. There is an emergency shutdown switch right here, and that's basically to shut down this charger from the vehicle. However, be mindful that this shutdown does not kill the system. It basically shuts the flow of electricity from the charger to the vehicle. We want to make sure that we shut down the main shutoff instead of just this initial shutoff for the vehicle. Okay guys, so talking about exposures. So our initial exposure is going to be side Charlie of the bank. Be cognizant that it is a bank, so it will be fortified. So forcible entry is going to be difficult if needed. We have a low overhang. So any fires involving the charging unit or transformer, there's a good possibility of it getting into the soffit and the eaves. We have secondary exposure of the large apartment building. Obviously, any vehicles located in the parking lot are going to be our primary concern. Damage to those vehicles, we want to keep at a minimum. So again, this is the charging unit, and we'll go on to our second location. Okay guys, so we'll talk about where our hydrant hookups is. So in our regards here, we're going to hook on at Champlain Street. So there's a hydrant there. We'll lay in the gutter. We'll go and then we'll pull our truck in. So we'll just nose our truck in right here. Be mindful that the parking lot can be full at times. If the parking lot is full, obviously we want to leave our truck a little bit further back, but the charging unit is at the rear of the building. Okay, Okay, so this is the second vehicle charger in town. So this has 3 separate stations where Scotiabank only has the 1 station. So there's the option to charge 3 vehicles at once with this style charger. It's a 500 volt DC, 125 amp, 50 kilowatt hour charger. It's a level 3 DC fast charger. We'll go around the charger. There is access via Delta once the power shut down if we have any fires internally. Obviously we can't open this up with any live power. We'll go around to side Charlie. On side Charlie we have the main power disconnect. So again, when we disconnect this, lockout, tag out, this is going to provide our means for shutting down this charger. There's also secondary disconnect in the building, in the breaker panel, which will basically cut the power off to this line. So remember, when we shut this down, we still have live power here. We do not have live power from the charger going to the vehicle. So dealing with exposures, guys, so our initial concern's obviously going to be the business that is adjacent to the charger. So we have an overhanging soffit, which will provide means of ingress for any flames here. We also have the parking lot on both sides, so we'll have potential for large amounts of vehicle exposures. We'll also obviously have the electric vehicle if the electric vehicle is charging at the time of the incident. So there's the potential to have electric vehicles parked around the charging unit itself. So remember, guys, de-energize the charger and then start attacking the fire. So be cognizant, we may have exposures already being impinged by fire upon arrival. So if we have to put an exposure line to the building prior to shutting down the charger, we can, but we cannot fight the charger fire until until the electrical power is shut down. So if we are unable to get to the main shutoff for the charging unit on side Charlie of the unit, then we would have to go interior of the building and shut down at the breaker panel. Note, entering into this switch box is 480 volts AC. So just be mindful when throwing the switch that there is the potential for arcing within the switch box. So obviously stand to the side and look away when operating the switch. So what we're going to do is we're going to go through parts of this alternative fueled vehicles training program through the NFPA. We're actually just going to focus on hybrid electric vehicles and electric vehicles tonight. So we'll go ahead and we'll click on this. And we'll just mute this lady. We're going to come over to the side and we're going to pick up charging stations. So we'll go ahead and we'll just do an overview of charging stations.
As discussed previously, electric vehicles require an external power source to recharge their high-voltage batteries. Plug-in hybrids also have the ability to recharge their battery through the use of a charging station.
Charging stations are classified as level 1, 2, and DC quick charge.
So for in town, guys, the 2 that we're going to be focusing on tonight are the DC quick chargers that are in town. One's at Scotiabank and one is at Subway. Bear in mind that behind the Case Populaire, there is one employee that daily uses a level 1 charger, so that basically just plugs into the wall. Level 2 charges are found more commonly at homes. They're a 240 volt charger, so those could very well be sprinkled throughout the municipality. But yeah, we're just going to focus on DC quick chargers tonight.
Charge port connectors for these units are the same on both passenger vehicles and trucks. A level 1 charger uses a standard 120 volt AC outlet for its power source, making it very portable. However, the rate of charge is limited and typically measured in hours. A passenger EV can take 10 to 24 hours to charge, while a medium or heavy truck could take days to charge with a level 1 charger, depending on the battery capacity. Level 2 chargers are fed from a 240-volt AC power source. These units can be seen in both commercial and residential applications and generally charge the vehicles in half the time as a Level 1. DC quick chargers provide 480 volts DC current and can charge a battery in a matter of minutes. It is designed to bypass the vehicle's onboard charging unit and charges the battery directly. This requires a different type of charging port and connector designed specifically for this purpose. These chargers will be used primarily in commercial applications such as store parking lots or rest stops where drivers need a quick recharging option. They will generally charge a vehicle in 30 minutes or less.
All right, so we're going to move on to initial response procedures. We're not going to go through it too much. We'll just kind of briefly go over it. So our initial response actions, we're going to want to identify, immobilize, and then disable. So with identify, we want to do basically a scene size up, figure out what we have, what we need, what's going on. So we want to identify if it's an alternatively fueled vehicle, and if it's charging, not charging, if it's involved in collision, involved in fire, etc., etc. Next thing we want to do is immobilize it. So that's where we want to put wheel chocks, turn the vehicle off, and then disable. So that's where we remove the keys, disable the 12-volt system, etc., etc.
In the next two sections, we take the information we learned about basic electrical concepts and components found in hybrid and electric vehicles and apply it to emergency responses. This section focuses on the initial response procedures to use on scene to quickly identify, immobilize, and disable these vehicles.
So are you involved in the accident?
Your initial procedures at incidents involving hybrid or electric vehicles are almost identical to those used with conventional vehicles. As we all know, following proper procedures at every scene is critical for the safety of responders. But this is especially true at scenes involving hybrid and electric vehicles. The first priority of emergency response personnel should be to ensure the safety of responders and civilians alike. As with any incident, a proper size-up is the first step to successful mitigation. Responders must be on the lookout for traffic, downed power lines, fuels or hazardous materials, and unstable vehicles. Specific vehicle hazards include sudden vehicle movement, electric shock, toxic or flammable gases, fires, and reignition. It's important to ensure that all responders are wearing the appropriate level of protective equipment for the potential hazards that may be present. A systematic approach when dealing with any motor vehicle incident will ensure a safe and efficient operation. A simple way to remember the proper initial response steps that start during size-up and continue through emergency operations is to use the Identify, Immobilize, Disable approach, or IID. This method can be used on any type of vehicle, including conventional ones.
Yeah, so as you guys can see, basically from our standpoint, dealing with electric or hybrid electric vehicles involved in fire or collisions, our response procedure is going to be the same. So we're going to treat it the same as a conventional vehicle. So we want to size up, we want to immobilize it, disable it, and then begin working on the vehicle. So we're just going to look on how to identify electric vehicles.
Be advised, unit coming in today, hybrid bus.
The first step in the IID process is to accurately identify the type of vehicle you are working with. Responders should always approach a scene with the assumption that they are dealing with some type of alternative fuel vehicle until confirmation otherwise can be made. The majority of the vehicles are based on existing conventional vehicle chassis, so never assume that you can easily identify a hybrid or electric vehicle based solely on the fact that it looks futuristic. One of the easiest identification methods is to look for badges or labels. They can typically be found on the outside of the vehicle, usually on the trunk or rear liftgate, the front doors, and front fenders. Some vehicles are marked on all four sides. Others are marked only on one. Badging such as hybrid, hybrid synergy drive, active hybrid, and others can usually be found in these areas. A badge reading electric for a zero emissions vehicle is an indicator of an electric vehicle. There are model names such as Prius, Leaf, and Volt that are only found on hybrid and electric vehicles. Keep in mind that badging can become hidden or dislodged during a crash. Even if badging is not immediately visible, do not assume it is a conventional vehicle. Responders should always check for additional clues. You can find hybrid or electric logos or other indicators on components under the hood and on the dashboard. For example, Honda uses the term Integrated Motor Assist, or IMA, to indicate the vehicle is a hybrid. This logo can be found in the engine compartment and on the dash of their hybrid models. As hybrids have become more common, at least one manufacturer stopped using hybrid badging due to the expectation that almost all vehicles will be hybrid or electric soon. More recently, SAE standards have called for badging of specific size and locations on passenger vehicles to aid in vehicle identification. Also consider that aftermarket and do-it-yourself kits are becoming available to convert conventional vehicles to hybrids. This is all the more reason not to rely on badging as the sole means of identification. Badging on trucks and buses is typically more limited, and there are no set requirements. Also, advertising wraps added when the vehicle is placed into service can hide some labels. There are other visual clues that indicate that you are dealing with a hybrid or electric vehicle. For example, orange wiring means that the vehicle has a high-voltage electrical system. Although this is often visible under the hood or in the engine compartment area, high-voltage cables running through other areas of the vehicle, especially underneath it, might be covered with protective material, effectively hiding them. The presence of yellow or blue cables in passenger vehicles indicates you are dealing with a medium or intermediate voltage system found in some hybrids. These should be treated the same as high-voltage systems. Another good identification method is to look for high-voltage warning labels, which can be found on the different high-voltage components and systems within the vehicle. On trucks and buses, it is typical to see warning labels on access panels to areas with high-voltage components.
Okay, so hopefully that kind of gives you guys an idea of how to identify a hybrid or electric vehicle. Just keep an eye out, always update your size up as you're working. If you find out that you're cutting on a vehicle and you see some orange high voltage cables, obviously relay that up the chain of command and make everybody on scene aware that you are dealing with a hybrid or electric vehicle. So we're going to move on to immobilize.
After determining an electric, hybrid, or plug-in hybrid is involved, the next step is to immobilize the vehicle. This prevents unexpected movement and provides a safer working environment. Always approach a vehicle involved in an incident from the sides. Never approach a vehicle directly from the front or rear, because until it is immobilized and positively shut down, there is always the potential for it to move unexpectedly. Upon reaching the vehicle, immediately deploy wheel chocks to prevent any type of accidental movement. Use wheel chocks of appropriate size for the tire. For trucks and buses, apparatus-sized wheel chocks are an appropriate means for preventing movement. In passenger vehicles, something smaller may be required. Next, engage the emergency brake and place the vehicle in park. In passenger vehicles, be aware that some will have push-button activated parking brakes. Since these are electrically operated, they must be engaged before the 12-volt battery is disabled. You may also encounter a joystick-type gear selector on the center console and a P button that is used to place the vehicle in park. In trucks and buses, the type of parking brake may vary, but on these types of vehicles, air brakes are common. Some automatic transmissions may be equipped with the P or parking feature, while others may only have a neutral position. Visit local dealers to familiarize yourselves with these features so that the first time you encounter them, it is not at an emergency scene. Now that you have made the vehicle safer to work around, it is time to shut down or disable it.
Alright, so now we'll move on to disable.
Hybrid and electric vehicles, for the most part, are disabled the same way as conventional vehicles. The shutdown procedures described here will disable the high-voltage system and, if equipped, the vehicle's airbags and seatbelt pretensioners. These steps are critical to ensure emergency responder safety. Keep in mind, however, that even after the high voltage system is disabled, the batteries still retain their charge, even if the rest of the circuit is isolated. The primary disabling method recommended by the manufacturers for passenger vehicles is to shut off the ignition and disconnect the 12-volt DC battery. This shuts down both 12-volt power sources, the 12-volt battery, and the DC to DC converter discussed previously. The simplest method to disable the 12-volt battery is to cut or disconnect the battery cable. Generally, you could cut the negative cable, but there are some exceptions. General Motors places cut tape indicators at the appropriate cut points in their vehicles. Using this procedure should be standard.
Another thing too to mention, guys, is all Tesla vehicles have a cut loop, a first responder cut loop as well. We're going to go into in just a little bit on where to locate those and how to find information on where to locate those, but they're the same principle as the GM cut marks, except in Tesla you just double cut the loop and then it shuts down the 12-volt system.
Policy on disabling any type of vehicle. A secondary method disables the vehicle in the event the ignition cannot be reached. First, disconnect the 12-volt DC battery. Next, locate the fuse that controls the high voltage system. It will be found in the engine compartment fuse block. And note that is not a high voltage fuse. It merely provides another means to disable the high voltage system. When pulled, this interrupts current from both 12-volt power sources to relays found in the high voltage battery. This opens a relay, shutting down the high voltage system and effectively disables the vehicle. Simply disconnecting the 12-volt battery alone does not prevent 12-volt current produced by the DC to DC converter from reaching the high voltage relays.
So another thing to note, guys, as I was just mentioning earlier about the Tesla cut loop, when you cut that, it basically cuts power from the DC-DC converter from the 12-volt battery. So it will, for better words, it basically shuts down input to the high voltage battery. So what that means is that normal functioning of the vehicle ceases. However, high voltage is still present anywhere from the motors through to the battery. So just keep that in mind when you cut that Tesla cut loop, that you're not disabling the high voltage systems, you're basically disabling the inputs to control them. So you're not going to have forward and reverse drive, you're not going to have 12-volt electrical systems on the vehicle. So just to keep that in mind as well.
If you have difficulty determining which fuse to pull, reference the NFPA EFG or the manufacturer's ERG to identify the correct fuse. If you are unsure which fuse is the correct one, pull all the fuses. Remember, if you haven't shut off the ignition, simply disconnecting the 12-volt DC battery is not enough to shut down the high voltage circuit. The DC to DC converter must still be taken offline as well, which is accomplished by pulling the high voltage system fuse. Likewise, if you just pull the high voltage system fuse, there will still be 12-volt DC power to the airbag and pretensioner systems. To fully disable the vehicle, both steps must be taken. Also keep in mind that after shutting down the high voltage system, vehicles equipped with an inverter converter to drive the electric motors will have capacitors which can take up to 10 minutes to drain down. Remember that the high voltage components and cables can still remain energized until the capacitors fully discharge. This secondary shutdown procedure applies to many of the most common hybrids, but you should always reference the vehicle's ERG or the NFPA EFG to determine the manufacturer's recommended secondary method. For trucks and buses, the primary shutdown procedure is very similar.
So in this case here, guys, we're just going to focus on the trucks. We're not going to look at the buses too much, just as we don't have any electrical buses in our region yet. However, delivery trucks are a prime source for hybrid electric vehicles.
The first step to disable the high voltage system is to turn off the ignition key and remove it from the vehicle. In most cases, turning off the ignition opens the high voltage relay. The second step is to access and disconnect the 12 or 24 volt DC batteries, depending on the low voltage system. In some cases, there may be a switch in or near the low voltage battery.
So again, this is pretty much the same procedures that we're going to use for all vehicle incidents. So just keep in mind, guys, that a lot of the stuff in here pertains to conventionally fueled vehicles.
Compartment. If not, responders should double cut or disconnect the negative battery cables. When disabling a 24 volt system, responders must choose the correct cable to cut. While you should choose the negative cable, it may not be as obvious as with 12 volt systems. Do not rely on the positive or negative.
So again, when you're cutting battery cables, guys, always cut the negative first. By cutting the negative first, you basically remove the ground from the vehicle so that when you're cutting the positive, you don't inadvertently touch a ground, causing an arc.
Negative markings on the top of the battery. Instead, look at the color and termination of the cables. The negative cable will terminate to a chassis ground and will be black in color. Also found on some models is an emergency shutdown feature. This can be as simple as a switch on the dashboard or a knob like this, located outside the battery compartment. With some manufacturers, activating this shutdown is the only way to fully disable the high voltage circuit. Due to the significant amount of variations in shutdown procedures found in commercial vehicles, use the ERG or EFG to determine the exact procedure. In many cases, you will encounter hybrid and electric vehicles that use a proximity key. This allows the vehicle operator to keep...
Okay, so basically what the rest of the video is going to talk about is proximity keys. Bear in mind, especially with Teslas, basically use your phone. So if you're in proximity with your phone, the vehicle will be alive, basically. A lot of conventional vehicles are like that these days with key fobs, so you don't have to put the actual key in the ignition, you just have to have it on your person or near the vehicle, and everything's keyless ignition. So with that respect, just if you can get these proximity keys, cell phones away from the vehicle, usually about 50 feet, then that's another way to shut down the vehicle. But never rely on that as a way to shut down the vehicle. Always rely on physical disconnection of the 12 volt system. So with that being said, guys, we're going to move away from initial response procedures. We're going to move into emergency response procedures. So the first thing that we're going to do is I'm going to go to charging stations first, because that's kind of what my focus, what I kind of want our focus on here first, and then we're going to go back and we'll talk about firefighting, crashes, and submersions. That way there, it kind of ties everything together.
Fires at charging stations should be handled based on your department's SOGs for fires involving energized electrical equipment.
So for us, guys, our SOGs for energized electrical equipment is we do not fight electrical fires until the electricity is shut down. So for our specific chargers, as you've seen at the beginning of this video, turn off the power to the chargers first, then commence firefighting operations.
Locate and shut down the power source before beginning firefighting operations. Remember that charging stations are fed from the electrical grid and use alternating current as their power supply. Treat the scene as a structure fire and take all normal precautions.
So basically, we would treat the scene as a de-energized electrical fire and a vehicle fire. So if the charging station is de-energized, then you treat the electric vehicle as a normal vehicle fire, and you treat the charging station as an electrical equipment fire. Obviously, if it has spread to a physical structure, then we treat the structure as a structure fire.
Associated with electricity in a structure. In the event of a collision involving a charging station, the same approach of shutting down power to the charger should be applied.
Say 1 Union Place for a CO investigation.
There are other types of emergency responses in which an understanding of how these vehicles operate will be helpful. You may respond to an incident involving carbon monoxide within a residence or structure. If there are hybrids or extended range electric vehicles in the area, they should be checked even if they do not appear to be running. They may in fact be in an auto stop or ready mode and still be on, periodically starting and running the engine.
As you can see, most of the procedures used during an emergency response with an electric or hybrid vehicle are the same as those used on conventional vehicles, with a few important differences. You've completed the emergency.
All right, so as you can tell, dealing with electrical vehicle charging system fires is not that difficult. Just have to remain cognizant that when the system is energized, we do not fight it. When it is de-energized, we fight it. So now we're going to go on to firefighting operations of hybrid and electric vehicles. The first thing I want to say here is there's a lot of misconceptions and myths regarding this. First and foremost is electric vehicles burn for weeks. In cases, yes, this is true, and it's basically because the fire department did not cool it adequately and the tow company removed it before it was safe to do so. So in this video, we're going to watch on how to properly cool down a high voltage battery pack and maintain it for the duration of the incident before handing it off to the tow.
While fires involving hybrid or electric vehicles are not considered to be any more dangerous or likely to occur than in conventional vehicles, they do present some unique characteristics that firefighters must understand to safely and effectively extinguish the fire.
So in this video here, guys, this is a Tesla Model S. It is one of the most powerful electric vehicles on the road today. And as you can see, these guys are operating next to it, so there's not an increased risk of operating near electrical vehicle fires, as you'll see coming up. Basically, the high voltage battery is isolated from the chassis, so we're able to operate around it. Now, if the battery is compromised, then obviously we treat that with added risk, same as if a fuel tank ruptured on a conventional vehicle.
The use of standard firefighting equipment is acceptable for extinguishing a hybrid or electric vehicle fire, since the high voltage system is electrically isolated from the vehicle's chassis and does not have an earth-ground reference. The electrical current does not seek a path to ground, preventing the electrical current from traveling up the fire stream. The use of NFPA-compliant firefighting ensembles with the SCBA provides the appropriate level of thermal and respiratory protection. However, firefighters should avoid direct contact with the high-voltage battery assembly and high-voltage components because structural PPE does not offer sufficient electrical protection. Because fires involving the high-voltage batteries take longer to suppress, some testing indicating up to an hour, it may be necessary for firefighters to exchange SCBA cylinders during the extinguishment process. If the high-voltage battery is not involved in the fire, handle that fire just like a traditional vehicle fire, using typical tactics and water supply requirements. As with any vehicle fire, be sure to chock the wheels as soon as it is safely possible to do so to prevent the vehicle from moving. Refer to NFPA's Emergency Field Guide and the manufacturer's Emergency Response Guide for information on shutdown and disabling the vehicle's high-voltage circuits. Since high-voltage battery fires can typically require more than 1,000 gallons of water to extinguish, be sure to establish a water supply from a hydrant or other water source. During a study conducted by the NFPA and the Fire Protection Research Foundation.
So ordinarily, guys, for vehicle fires, we wouldn't capture a hydrant first, so we wouldn't be laying into a vehicle fire. Usually what would happen is we arrive on scene of a vehicle fire, determine that it is an electric or hybrid electric vehicle, and then we would have to either have the second in pumper lay in to us or have a member stretch line to a hydrant to basically supplement our water supply needs.
One electric vehicle high voltage battery fire took over 2,600 gallons of water to fully extinguish. In a separate test, firefighters used approximately 4,000 gallons to ensure the battery was fully extinguished. As new electric vehicle models are released, ever-increasing battery sizes may require even more water to cool the battery pack effectively. When responding to an area without a reliable water supply, the company officer should request at least one additional engine and should be prepared to establish a water shuttle operation, especially in an offensive fire attack operation. The tests conducted on passenger vehicle-sized batteries provide a baseline estimate that will likely translate into longer suppression times with trucks and buses because their high-voltage batteries are often much larger. Failure to establish an adequate water supply prior to making an offensive attack could result in running out of water prematurely. If the fire reignites, there may not be any water left over to protect potential exposures. The same principle applies here as with the use of firefighting foam. Ensure that you have enough extinguishing agent, in this case water, available on scene to provide a better opportunity to maintain the constant flow required to extinguish a high-voltage battery fire.
One thing that's not covered here is that Tesla recommends not using foam when extinguishing their vehicle fires, and we'll look at that in a second, where you can find that information and how to use it.
When dealing with a high-voltage battery fire, always consider the size of the battery and its location within the vehicle. In hybrids, the batteries are typically located in the rear of the vehicle. They are accessible through the cargo space, allowing for more direct water application. Electric vehicles, on the other hand, have much larger batteries that are typically located in harder-to-reach areas, such as under the floor pan. In these models, it is more difficult to get water directly onto the battery. Low ground clearance can also make reaching the underside of the battery area difficult. On trucks, the high-voltage batteries are attached to the frame rail, which is more accessible. In some instances, the batteries may be mounted on the inside of the frame rails, which will limit accessibility. Always consider the extent of the fire within the battery and look for any pre-existing openings, such as air vents, into the battery case that will allow the water to directly reach the burning cells. Determine the location of the high-voltage battery within the vehicle by referencing NFPA's Emergency Field Guide or the manufacturer's Emergency Response Guide. For quicker extinguishment, keep a continuous application of water on the area that is burning for a prolonged period of time before moving on to another section of the battery. Also, continue to apply water after flames are no longer visible to sufficiently cool the battery pack and reduce the risk of reignition. In the event the high-voltage battery catches fire, it may be preferable to allow the fire to continue to burn inside the battery case until the electrolyte is burned out, if the situation allows. Since the case is sealed, it is difficult, if not impossible, to get the extinguishing agent directly onto the burning cells. The only way to stop the fire from propagating from cell to cell is to put a sufficient amount of water on the outside of the case to cool the battery down and stop the reaction. Use caution when operating near the rocker panels, as pressurized flames may be released from the battery vents. This is part of the vehicle's safety systems and should be allowed to occur. If ground clearance is restricting the ability to apply water effectively to the battery case, consider the use of lifting struts to provide a better angle, if it is safe to do so. The placement of the struts depends on the damage to the vehicle and any potential hazards present. Also, once the main body of fire is knocked down, especially if access to water is limited, consider a low-flow, low-pressure application to the battery case to reduce the amount of water that is deflected without contributing to the cooling process. If the decision is made to allow the battery to burn, be sure to protect any...
So in this case here, what we would probably use if we were going to do a prolonged cooling on the underside of a vehicle, use our deployable master stream, and then run a 1-2.5 inch at approximately 30 to 50 psi tip pressure, and then we would open it right up to 1,000 gallon per minute nozzle flow. That way we would basically reduce the velocity of the water leaving the nozzle tip of the portable master stream, which would aid in preventing dispersion from the underside of the vehicle, basically allowing our stream to absorb as much heat energy as possible.
exposures. As with materials found in conventional vehicles, the burning of a battery can produce toxic materials, so SCBA must be utilized. Also, bystanders should be kept clear of smoke and combustion byproducts. Never pierce, cut, pry, or dismantle the battery case or floor pan in an effort to get water directly into the battery, because you may come into contact with high voltage components, risking potential injury. Before removing a vehicle from the scene, monitor the battery area for any hissing or popping noises and smoke. If there is visual access to the high voltage battery, use a thermal imaging camera to determine if the battery has cooled down or if it is getting hotter over time.
So the use of a tick, guys, is incredibly important, especially early on into the firefight. So if you have a vehicle fire that is not involving the high voltage battery, and we let the fire progress to the battery, then obviously our job just became 10 times more difficult. We've now increased the risks, we've now increased the exposure, etc., etc. So if we can use a tick to determine the level of heat in the battery pack itself. So if we're talking a full electric vehicle, basically it's the entire floor pan of the vehicle is the battery. We're going to want to make sure that if, let's say, an electric motor caught fire, we want to make sure that we isolate the battery through cooling from the fire itself. So we may cool the battery first as opposed to extinguishing the fire immediately. So you may even have two lines on the vehicle. But we want to make sure that that high voltage battery pack is as cool as possible. And before we release the vehicle to the tow operator, we want to make sure that that battery pack is at room temperature. So that's one thing that's stressed in the industry, is that the vehicle must be at room temperature, including the high voltage battery pack, before releasing it to tow. So a lot of these stories that are floating around where these vehicles have burnt for days, weeks, etc. In salvage yards is because the vehicles were released to tow before the high voltage batteries were discharged or cooled back to room temperature. So that's one thing we really have to make sure that we do, is that before we leave the scene, that the battery itself is cooled to room temperature. So if it's a 30-degree day, we want to make sure it's around 30 degrees. If it's a minus 30-degree day, we kind of want to make sure that it's around 15-20 degrees Celsius. So we don't want to make sure it's minus 30, but we want to make sure that it's around room temperature in a house, etc.
If the battery continues to heat up, it indicates the fire is still active. The usefulness of thermal imagers are limited, however, by your ability to visually access the battery case.
So in that case there, again, especially on fully electric vehicles, looking at the underside of the vehicle, usually the floor pan, offers the most direct route to the battery itself.
Possibility of reignition. NHTSA and NFPA guidelines currently recommend vehicles be kept at least 50 feet from any combustible materials when stored post-fire or when there is any damage to a high-voltage lithium-ion battery. The goal is to protect any potential exposures should the battery reignite. This guideline, however, was designed for smaller passenger vehicles, so consideration should be given to increasing the distance based on the size of the vehicle. Firefighters should follow.
And again, primarily batteries that reignite usually are from damage and are usually from not being cooled enough. So we don't want to just bring it to room temperature, we want to bring it to room temperature and monitor. So if we see that that temperature is starting to rise spontaneously, then obviously that there's an issue with the battery pack itself and we want to continue to cool.
Follow recommended disabling procedures as soon as possible and before overhaul operations take place. During the overhaul process, avoid contact with high voltage cabling and components. Even if standard disabling procedures are followed, there is the potential that the relays and the high voltage battery may have fused in the closed position if they were exposed to enough heat. This would keep the high voltage circuit energized even if the vehicle were shut down. Always remember, while special equipment is not needed to fight fires in hybrid or electrical vehicles, securing an appropriate water supply and following the water application techniques outlined in this training will result in a more effective extinguishment operation. Additionally, consider that a damaged lithium-ion battery poses a delayed fire risk, which could occur hours or even days later. Notify a dealer or manufacturer representative that you have a damaged battery. Also, a tow operator should be informed not to store a severely damaged vehicle containing a lithium-ion battery within 50 feet of a structure or other vehicle until the battery can be properly discharged.
Okay, so that's pretty well as much as we're going to focus on in this program here. So we're going to go ahead and we are going to come up here. So what we're going to look at is how to gain access to emergency response guides. So Tesla has a very, very great program. So you basically go to Tesla and then you go to first responders information. It's up in the tabs, and then you come down here and they have emergency response information for every vehicle out there. So the world's most popular electric vehicle on sale today, with I think 70% of all electric vehicles on the road, is the Model 3. So what I have here is I have pulled up the emergency response guide, quick response sheet. So the quick response sheet basically shows this is primarily more along the lines for extrication, but as you can see, what I wanted to show you guys here is this orange here is the battery pack. So you can see that the battery pack is primarily the entire floor structure of the vehicle. This, here, I'll zoom in for you guys. This right here is the first responder cut loop, so it's located under the front lid. Basically right kind of where the gas struts are in the lid, there's a cut loop there, and then that disables the 12 volt electric system. And again, this is the basically quick response sheet. So with firefighting, we want to use water to fight the high voltage battery fire. If the battery catches fire and is exposed to high heat or is generating heat or gases, use large amounts of water to cool the battery. It could take up to 3,000 gallons of water applied directly to the battery. So when it says 3,000 gallons of water applied directly to the battery, probably add 50% to that, or 100%, sorry, to that. So it would be 6,000 gallons, because a lot of the water is not going to be making it to the battery. We can extinguish small fires not involving the battery using typical vehicle firefighting procedures, so just normal fire attack. Always use insulated tools for overhaul. We're not necessarily going to overhaul the vehicles that much. If we are going to overhaul the vehicles, be cognizant of the orange wiring, and remember that if involved in a fire, the orange loom melts away rather quickly, so just keep that in mind. So heat and flames can compromise some components, result in an unexpected explosion. Perform adequate knockdown before entering the hot zone. So that's attacking the vehicle from 50 feet away on the 45-degree angle, and then making our way into the hot zone. There must not be fire, smoke, or heating present in the battery for at least 1 hour. Consider using a tick to measure the temperature, and the battery must be completely cooled before the vehicle can be released to second responders, i.e. tow. Always advise second responders, i.e. tow, that there's a risk of battery reignition. So this is where we're saying we want to make sure that these batteries are cooled down to room temperature and that they don't reheat by themselves. Then there's warnings, and then there's how to stabilize the vehicle. So chalk the wheels, set the parking brakes on the end of the gear stock, and then disabling the high voltage system. This here I believe is charging ports. So basically, if the 12 volt system is disabled, you can pull this cover out and you can add 12 volts to it to operate some systems. So one thing to know with Teslas is that the parking brake is a 12 volt system. So be sure to engage the park brake before disabling the 12 volt system. Otherwise, you have no parking brake and the vehicle is free to move how it chooses. And then this is the cut loop that I was talking about. This is the 12 volt cut loop. And as you can see, it's located in the front on the driver's side, and there is a little, there's a red wire loom with orange tape on it, and we make two cuts. Make the two cuts so that the memory of the wire is removed so that they don't rejoin, and it's located up near the strut assembly. Okay, so that's just a QR sheet. A lot of manufacturers have something similar, but every manufacturer pretty well has an emergency response guide for their hybrid or electric vehicles. We're not going to go through this too much. You guys can look through it on your own time. But one thing I wanted to basically go through with you guys is firefighting. So we're going to go down here and click on firefighting. And again, it brings up the fact that we want to use 3,000 gallons of water. And it says if water is not immediately available, use dry chemical, CO2, foam, or other typical fire extinguishing agents to fight the fire until water is available. So again, Tesla wants water. They don't want anything else. They primarily want water. It says apply water directly to the battery if safety permits. Lift or tilt the vehicle for more direct access to the battery. If tow is on scene, they may be able to hoist the vehicle, and we could just chalk it. Not chalk, but block underneath to stabilize in an elevated position. And then apply water inside the battery only if a natural opening such as a vent or opening from a collision exists. So we don't want to open up the battery at all. Extinguish small fires that don't involve the high voltage battery using typical firefighting procedures. Don't make contact with high voltage components. Battery fires can take up to 24 hours to extinguish, so consider allowing the battery to burn while protecting exposures. This is only kind of like a last resort thing. Obviously, we want to make basically make an attack on it as much as possible. If we're not getting anywhere, then obviously leaving it burn is an option. Second responders may choose to drain excess water out of the vehicle by tilting and repositioning it. This operation can assist in mitigating possible reignition. And then it says, due to possible reignition, store at least 50 feet from any exposure. So that's pretty well specific to the Model 3. If we want to go to a field guide, which is basically more generic, there's the emergency field guide from NFPA, and it's a free resource, so anybody can pick it up and look at it. I have it pulled up here. This is the most current one. It's a 2018. And on the sidebar here, we can see that it deals with initial response, vehicle identification and mobilization, disablement, primary shutdown methods, secondary shutdown methods, crash extrication, crashes, extrication, stabilization, ultra-high strength steels, hybrid and electric vehicles, damaged high voltage batteries, manual service disconnects, hydrogen, gas, etc., etc. Extinguishment agents, offensive attack, defensive attack, fires involving charging stations, overhaul and recovery, hydrogen fuel cell, gaseous fuel vehicles, compressed natural gas, liquefied petroleum gas, overhaul and recovery, submersion, and then it goes into various manufacturers, what to do when it comes in contact with alternative fuels, and all of the manufacturers. So you can see it's a quite lengthy document and there's a lot of information in it. One thing that I will touch on is the charging systems. If we can find it. Fires involving charging stations. So it wants us to locate the power source from the charging station, shut it down until power to the charging station is cut. Treat the fire as you would an energized electrical fire, which in our case means that if it's a large fire, we do not touch. If it is a small fire, we use recommended CO2. We only have dry chem, so we're going to use ABC dry chem. And then if a vehicle is plugged into the charging station, it should be unplugged as soon as possible when it's safe to do so. And if possible, shut down the charging station first. So if we can shut down the charging station first, we would do that, then unplug the vehicle. If not, unplug the vehicle if it's safe to do so, and basically isolate the two systems. So other than that, guys, if you guys want, you can email me and I'll send you links for all these things, and I can get you guys hooked up if you want further reading material. everything is pretty easy to find. Again, Tesla has a really not sophisticated, but a really up-to-date and well laid out emergency responder website. And then off to the side here, under advanced extrication, you can find Model S, I believe, and Model 3 auto extrication videos, procedures, etc., etc. And then these here obviously deal with extrication and rescue as well. So we'll end it here, and any questions can be directed towards me, and we'll see if we can get that information passed down to the guys. So what I'm going to do here is I'll just let some B-roll play while I go through a bit of information for you guys. So electric vehicles are designed to be immobilized while charging. So that basically means that while electrical vehicles are charging, you can't move them. So if you jump in them and try to pull away, you can't pull away. Basically that prevents any disconnection from happening. It's kind of the same way that if you're at a fuel station and you try to leave with the hose connected, there's a quick breakaway. In this case, you just can't leave with the vehicle. In case of collision, deem whole site is energized and turn off main power supply. So that's dealing with a charging station. In case of a fire, charging cable connection is designed to melt away, disconnecting the vehicle. So basically, if it's involved in heavy fire, that charging cable will melt and will then isolate the vehicle from the charging facility. According to Tesla, charging stations are deemed to be fought as electrical fires, while electrical vehicle fires are to be deemed as vehicle fires and fought as such. Electrical fires should be extinguished by CO2 primarily, and the reason is because it doesn't corrode any of the electrical or electronic components the same way that ABC extinguishers would. However, if ABC is the only, like dry chem is the only extinguisher available, then absolutely use that to extinguish any small fires. Vehicle fires should be extinguished by water. Smart electrical vehicle fires, not including the high voltage battery with ABC CO2. And then again, arrival on scene, we want to size up, immobilize, disable, and then begin firefighting.
Engine 5585, vehicle fire, reported to be an electric vehicle, Highway 104 near the county line.
Dispatch engine 5585 responding.
The fire service responds to over 200,000 vehicle fires annually, just in the U.S. alone. With the increased popularity of hybrid and electric vehicles, your chances of encountering a high voltage battery in a vehicle fire increase every day. In this short training video, we've teamed up with CAL FIRE, the NFPA, and Advanced Extrication to bring you best practice when responding to electric and hybrid vehicle fires. One important step when responding to an incident involving a hybrid or electric vehicle fire is to identify the vehicle. This identification process starts with the reporting party, but it may be that we arrive at the incident and then have to identify the vehicle from there. This can be difficult when the vehicle is involved in fire. After the knockdown of the vehicle, which will be handled in the same way as a conventional vehicle, we can take the necessary steps to identify the vehicle. The formal identification for a hybrid or electric vehicle is simply the badging and branding on the outside of the vehicle. We can look on the inside of the vehicle for our informal identification, possibly in the engine compartment, trunk, luggage compartment, or just throughout the vehicle. More information on identifying high voltage vehicles can be found by visiting Advanced Extrication's website or the NFPA's EV Safety Training Program. Once we've identified that we're fighting fire at a hybrid or EV, we need to find the battery. Locating the battery is important for two reasons. First of all, we need to make sure that we're able to cool the battery if it's been exposed to heat. This will require locating the battery in the vehicle. We also want to identify the location of the battery so that we avoid it during our overhaul operations. We never want to cut or crush a high voltage battery or open it up to extinguish it. The personal protective equipment required for responding to a hybrid or electric vehicle fire remains the same as a conventional vehicle. SCBA and full structural PPE are adequate protection for responding to vehicle fires involving high voltage batteries. As we mentioned earlier, it's important to apply our water directly to the high voltage battery in order to effectively cool it. It's not always possible to get direct access to the battery. In most hybrid vehicles, we can lift up the luggage compartment or trunk area to apply water to the battery. If that area has been involved in fire, much of the battery coverings may be melted away, giving you better access. On vehicles with floor pan mounted batteries, we may need to lift the vehicle slightly in order to get water onto the floor pan battery. If conducting that technician level operation, be sure that your personnel are trained and equipped for the task and that care is taken to not interact with that battery during your lifting assignment. To evaluate if a battery has been exposed to heat or if it's involved in thermal runaway, we can simply observe the battery and listen to the battery. If we see smoke or steam coming off the battery or we hear any popping noises from the battery, this indicates that the battery is involved in a thermal event. We can also use our thermal imaging cameras to evaluate the battery's temperature. If the battery requires cooling, we simply use water to cool the battery. Directing your hose stream at the battery in one location that's been heated for a period of time and then moving on to another location in the battery was found to be best practice rather than sweeping the battery with your hose stream. How the heat and fire spread through a battery varies dramatically. The variables are based on how the manufacturer has put the battery together, the charge of the battery, and where the battery was exposed to the heat. Water has been identified as the best extinguishing agent and cooling agent for lithium-ion high-voltage battery fires. Research and case studies have proven that it can take between 500 and 8,000 gallons of water. Later, we'll talk about actively cooling the battery, and we'll cover best practice for application of water onto the high-voltage battery. But keep in mind, suffocating agents such as foam and dry chemical are going to be ineffective in cooling your high-voltage battery. In addition to cooling the battery with the application of water on the case, we can also effectively cool the battery by applying water inside the battery. This is only possible when a vent or other natural opening has occurred, like in the case of a collision ripping the battery partially open. If we have the opportunity to apply the water inside the battery, this is the most effective way to cool it. Keep in mind, at no point during the incident should you attempt to open up the battery to apply water to the inside. It's only conducted when we can do it through a vent or an opening created by the accident. Cooling the battery is very simple. A long, continuous stream of water applied to the case of the battery is the most effective way to reduce the temperature within the battery and limit thermal runaway. The application of our hose stream should be placed on an area of the battery where heat is determined. We can determine where the battery is heated with our thermal imaging camera or visually watching the battery for areas where smoke and steam are venting from the battery. That application of water should take place for an extended period of time and not be interrupted. Once we see visually that the battery has been cooled, either determined by no more smoke or steam coming off the battery or a clean reading with our thermal imaging camera, we can stop our cooling efforts. At this point, monitoring the battery again for smoke or steam coming from the battery or with our thermal imaging camera for 45 minutes before we release the vehicle to second responders is appropriate. If at any point during our waiting period we see any indication of heat buildup, water should be again applied to the battery. Typically, when interacting with a hybrid or EV at a roadway incident, we're going to take action to shut down the high voltage and isolate it to the battery. We do this through the first responder cut loops or the high voltage disconnects within the vehicle. We also disconnect the 12-volt battery and often turn off the ignition to perform this operation. With high voltage vehicle firefighting, that operation remains the same, although you may not be able to access some of these components due to the damage created by the fire. We're going to use any system that's still intact to perform that operation, but keep in mind it may not be possible due to the fire damage to the vehicle. In most situations, the vehicle will have performed this operation on its own due to the high voltage relays in the battery. This means that we can operate as if we're at a conventional vehicle with the exception of interacting with those high voltage components.
Let's take a look at our Tesla Model S training and research burn conducted in March of 2019. A 400,000 BTU torch was directed through an opening in the battery, and over 3,000 degrees was applied directly on a module. The torch was left in place until fire had spread beyond the battery into the front trunk and wheel well of the vehicle. This took approximately 13 minutes. In this test, the heat applied resulted in thermal runaway to 2 modules. Firefighters were then directed to extinguish the fire and cool the battery. Knockdown was found to be a simple operation, and the crew was directed to lift the vehicle in order to direct the hose streams at the floor pan battery. At this point, the battery was checked with a Scott thermal imaging camera. Cooling operations began, and water was directed at the hottest area of the battery for nearly 10 minutes. The battery case was then checked again after the cooling operation had been stopped for 5 minutes. This time was given to allow any potential heat to transfer from the cells of the battery onto the battery case. The battery case was found to be over 200 degrees Fahrenheit, and cooling operations began again. Cooling continued for another 8 minutes until the battery was found to be sufficiently cooled. The vehicle was monitored for 45 minutes and no signs of thermal runaway were detected. The entire operation used approximately 4,000 gallons of water, and the vehicle did not reignite at any point after the testing.
Once the battery temperature has been reduced to approximately the outside ambient temperature, and that temperature has been maintained without the application of water, again for 45 minutes, we're ready to release the vehicle to second responders, including law enforcement and tow. It's our responsibility to help educate our second responders on the proper storage and transport of the vehicle. The vehicle should be kept 50 feet away from any exposures wherever it's being stored. This is because there's always a chance of reignition days or hours after the incident. In addition, we can request that our second responders prop the vehicle up and position it in a way where any water that has gathered inside the battery drains out of one of the openings. In this short video, we covered the various operational considerations and tactics required to effectively and efficiently mitigate fires at vehicles equipped with high voltage batteries. The process for extinguishing a high voltage vehicle fire is no more challenging than that of a typical conventional vehicle. Remember to establish your water supply early and expect a longer commitment time. Cooling the battery directly with water is the appropriate extinguishing agent. We want to thank CAL FIRE, Tesla, and the NFPA for their support in the research development and the creation of this training video. I'm Brock Archer with Advanced Extrication. Take care and be safe.